Hello everyone, welcome to Easy Ganit. This is Samir Sudhana. So guys, in the series of 200 must-do Quant question for Snap, I'm doing this next topic, that is geometry. I have already covered 10 questions of geometry in the previous video. This is part 2 of geometry where I'll be starting with question number 11. So guys, we have covered these 10 questions along with the theory discussion. Right. So now let's start with question number 11. So guys, I'll be taking questions of circle and similarity in this video, right? Which is an important topic for snap exam point of view. Guys, this is a very important property, right? In the circle, that angle between any chord and the tangent at the point of tangency is equal to angle subtended by the chord on any point on the circumference of the alternate segment. What is the meaning of it? See guys, you can see that here angle subtended by any chord. You can see that this PT is a chord of a circle, right? Angle subtended by the chord and tangent, this is a tangent, right? You see that angle between this chord and tangent is this particular angle. This value of this angle will be same as the angle subtended by this chord in the alternate segment of the circle. Now this chord PT is making this angle in the alternate segment of the circle. So these two angles will be equal in length. This is called as alternate angle segment theorem, right? The theoretical sessions on geometry, which I have given to you in the description part of the video, you can check the proof of this theorem. This is known as alternate angle segment theorem. That means if the value of this angle is theta, then this angle will also be equal to theta. Similarly, you can see that this is also the angle between the chord TC and the tangent BA at the tangential point T, and this angle is the angle made by the same chord in the alternate segment, so this angle will also be equal to alpha. This is known as alternate angle segment theorem, and it is used in many questions, guys. Look at this question, a beautiful question in the figure given below, not drawn to the scale. A, B, and C are the 3 points of the circle with center O. The chord BA is extended to the point S such that CS becomes a tangent to the circle at point C. If angle ACS is 30 degree, guys, this angle is given to us as 30 degree, and angle ACS, this angle is given to us as 50. We are supposed to find out the value of angle BOA. So guys, here this is 30, this is 50. Can I straight away say that the value of this angle will be 100 degree, right? If this is 100 degree, then this angle will be equal to 80 degree. Now see that, guys, this angle is 50 degree. The angle subtended by the chord AC in the alternate segment will also be same as 50, the property that we have just studied. Now this is 50, this is 80. So can I say the value of this angle will be equal to 50 degree, right? So angle made at the center of the circle, will be twice of this angle. So this angle will be 100 degree, and this is the correct answer to the question. The value of angle BOA will be 100 degree, guys. Now let's move on to question number 12. Question says the incircle of triangle PQR touches the three sides PQ, QR, and RP, and the triangle at ABC respectively. Just quickly go through the information, guys. The straight away, what we are supposed to find out is the measure of all the internal angles of the triangle. These are the angles that we are supposed to find out, guys, right? These are the three angles that we are supposed to find out. Say this, guys. Look at this angle. If this angle is given to you as 40 degree, right? See that, guys, this angle is given to us as 40 degree, right? This is the angle subtended by the arc AC, by the chord AC, right? The 40 degree angle, is the angle, this angle is subtended by the chord AC. Now can I say that angle between the chord and the tangent of the circle will also be equal to 40 degree, right? See that this is the angle subtended by the arc AC in the alternate segment of the circle. Can I say that value of this angle will also be equal to 40 degree, right? Now this is 40 degree, this will automatically become 80 degree, right? Okay. All right. Now you also need to look at this angle. You see that this is also the angle between the chord and the tangent. The angle between the chord and the tangent of the circle at the point B will be same as the angle made in the alternate segment. That means this angle will be equal to 80 degree, right? Now this is 80, this is 80, so therefore the value of this angle will be equal to 20 degree, right? Similarly, similarly guys, if I have to look at the value of this angle, this is also the angle made between the tangent and the chord, this will also be equal to 40 degree, right? This is the alternate angle segment theorem that we are applying. This is 40, this is 40, so therefore the value of this angle will be equal to 100 degree. Now, if I have to look at this angle, this is the angle between the chord AB and the tangent PQ. And this angle will be same as the angle made by this chord in the alternate segment, which is 60 degree. So this angle will be 60. Similarly, this is also the angle between the chord and the tangent, or you can say that this is 40, this is 80, so this has to be 60. So this angle will finally be equal to 60 degree. So all three angles, right? Angle P, angle Q, angle R of the triangle will be 100 degree, 60 degree, and 20 degree respectively. This would be the correct answer to the question. Moving on to the next question, question number 3. ABC is given to us a triangle whose longest side is 20 centimeter. You see that, guys? This length is 20. If the length of the other side is 10 centimeter and the area of the triangle is 80 square centimeter, guys. So we are discussing now the questions related to the area of triangle, guys. Area of triangle, everybody know, is half into base into height. Now this area of triangle is given to me as 80, right? Now half base, if I take the base as 20, then the height, that means the perpendicular distance of the altitude from the base, the perpendicular distance of the vertex from the base BC, right, that is h, right, this value, you can see that this value h will be equal to 8. Now the altitude is equal to 8, right? Now see guys, now because this is an altitude, can I say this will be a right angle triangle? Now what we are supposed to find out is the length of the third side. This is the length that we need to find out. Guys, can I apply a triplet here? This is 10 centimeter, this is 8, so straight away you can say that this would be 6 centimeter using Pythagoras theorem. Now the whole length is 20, this is 6, then this would be 14 centimeter. So the length of AC would be square of 8 plus square of 40 using Pythagoras theorem. This would be 64 plus 196, that means this will be equal to 260. So length AC will be equal to 260, guys. Question number 14. It says that PQRS is a quadrilateral and PQRS are the points on the circumference of the circle with PS as a diameter of 16. Okay. So first we need to draw a circle. All right. Now question says PQRS is a quadrilateral and PQRS are on the circumference of the circle with PS as a diameter of 16, guys, right? PS is a diameter of length 16, right? Now this is PS, let's say PQRS. All right. So this is P, this is Q, this is R, and this is S. PS is a diameter of length 16. PQ is given to us as 8, QR is also given to us as 8. RS is not given to us. We are supposed to find out the area of this quadrilateral. Alright. So guys, what you can see here in the question is, if PS is a diameter, can I say that this is the side O? This is the center of the circle. Can I say the length of PO will be 8 and the length of OS will also be 8? Now once you know that PO is 8 and OS is also 8, what I can do is, can I join Q with O? Now Q with O will be the radius of the circle, guys, right? Q to O, guys, the length of QO will be radius of the circle. Similarly, OR will also be the radius of the circle. This is 8 and this is 8, right? Now guys, you can see that look at the triangle POQ. All the sides are equal, so can I say all the angles will be 60 degree? Look at the triangle QOR. All the sides are 8, so can I say all the angles will also be 60 degree? This angle will also be 60. This is also 60. This is also 60. Because these two triangles are equilateral. So this angle automatically becomes 60. And this is 8, this is 8, so this will also be equal to 60 and 60. So this will also become an equilateral triangle, and this will be 8. Now, look at the complete quadrilateral PQRS. The complete quadrilateral PQRS is made of 3 equilateral triangle of side 8 centimeter. Now, area of equilateral triangle is root 3 by 4 a square, right? This is the area of triangle. Now, area of one equilateral triangle is 16 root 3. Area of one equilateral triangle is 16 root 3. And we have 3 such equilateral triangle. We have 3 such equilateral triangle. So area of the quadrilateral PQRS. Area of the quadrilateral PQRS will be equal to 48 root 3. This would be the correct answer of the question, which is option B. Beautiful question, guys. This is the point that you need to see, that if I join the radius with the vertices of the quadrilateral, you will be getting 3 equilateral triangle, guys, right? And then you can finally find out the area. Okay, now here's the next question, question number 15, guys. It says that PQ in the following figure, if D divides AC in the ratio 5:3, or D is dividing the side AC in the ratio 5:3, find the area of triangle of ADB, BDC and ABC. We are supposed to find out the ratio of the area of triangle. So this question is actually very basic. This is only to help you understand the basic theory, that if in a triangle, right, we know that area of triangle is half into base into height. Now if two triangle have the same height but different base, right, if two triangle have the same height but the different base, let's say first triangle have the base B1 height h, and the second triangle has the base B2 but the height is same. If two triangle have the same height, right, but different base, in that case the ratio of the area will depend on the ratio of the base of the triangle, right? Ratio of area of triangle will be same as ratio of the area of the ratio of the base, right? Ratio of the area of triangle will be same as ratio of the base of the triangles, right? So therefore this is something very important. How would you know that triangles have the same height? If the bases of the triangles lies on the same line, if the base of the triangles lies on the same line and they have the same vertex, and if they have the same vertex, in that case you can say that height would be same. For example, in this triangle, look at the triangle ADB, BDC and ABC. Look at these 3 triangles. If I look at these 3 triangles, you see that the ADB, right, the area of ADB would be half into base AD multiplied by the height. Now height, let's say, is h. What is height? Height is a perpendicular distance of the vertex from the base, right? This would be the height of the triangle ADB, right? Because you can see that vertex is B for AD, triangle ADB, and the perpendicular distance on the base AD would be h. Similarly, if I look at the triangle BDC, this would be half into base DC. Height of this will also be h because it has the same vertex B. And the area of triangle ABC would be half into base AC multiplied by the height. Again, that height will still be h, right? Now, area of all of these 3 triangles will depend on the ratio of the area of triangles will be dependent on the base ratio, right? AD is 5, DC is 3 and AC is 8. So the ratio of the area of these 3 triangles will be 5:3:8. Now this is an easy question, but keep the point, keep the learning in your mind, that if triangles have the same height, then the area ratio would be same as a base ratio. This is something which is very important, and using this we will be doing this question. Look at the question now. It says that in the given figure is a triangle STU. ST is given to us as 8 centimeter. TU is given to us as 9 centimeter. SU is given to us as 12. Now the length of QU. QU is 12, so can I say QS will be 12, QU is 24, so can I say QS will be 12? Now SR is 32, SR is 32, so ST is 8, so can I say TR will be 24, right? PT is, the value of PT is 27, where TU is 9, so can I say PU will be equal to 18? What is the ratio of the area of triangle PQU? You're supposed to find out the ratio of the area of triangle PQU to the area of triangle PTR. Okay, very easy question, guys. If you observe carefully, if you use the property that we have just discussed, right? Look here, guys. Look at that. See this, guys. Let's say that area of triangle TSU is, let's say, 1, right? Let's say that area of this triangle is 1, right? Let's say this is a this area is 1, right? Area of the middle triangle STU is 1. Now if I join T with U, look carefully now, guys. Look at these two triangles, guys. Look at the triangle, look at the triangle STU and the look at triangle UTR. In both of these two triangles, you see that the height vertex is same as U. Base ratio is 8 and 24. 8 and 24 are in the ratio 1:3. So if this area is 1, can I say this area will be equal to 3? Right. Now look at this triangle. You see that now? On the base of 9, if the area of triangle is 3, on the base of 18, the area of triangle will be 2 times of 3, that is equal to 6. This will be 6, right? Similarly now, guys, what you can do here is, look at, if I join Q with T now, right? See this. Look at this triangle now. Look at this triangle. These two triangles have the same vertex T. On the base of 12 we have area 1, so this is also a base of 12, so this area will also be 1, right? Same base, same height, that means area will definitely be same. Now see this, on the base of 8, look at this triangle now. Look at the triangle STQ and then look at the triangle TRQ. On the base of 8 we have area 1, on the base of 24 we will have the area as 3. This area would be 3. Okay, now what you do is join P with S, guys, right? See this, guys. Now on the base of 12, right, what we need to do now here is, right, on the base of 9, look at the triangle PUS and SUT. On the base of 9 the area is 1, on the base of 18 the area will be equal to 2, right? Now this area will be equal to 2, right? Similarly now, look at these two triangles now. Look at the triangle PSU and the triangle PQS. Now this is the base of 12, this is the base of 12. On the base of 12, area is 2. Again, this is also a base of 12, so the area of triangle PSQ will also be equal to 2. Now we are supposed to find out the area of triangle PQU. Look at the triangle PQU. This complete triangle is having an area of 4. So triangle PQU has area of 4. To the area of triangle PTR. Guys, look at the triangle PTR. PTR is 6 plus 3, that is 9. So area of triangle PTR would be 9, right? So 4:9 is the correct answer to the question, guys, right? This is a very important property that we have just discussed, guys, right? Keep this property in the mind whenever you are solving the questions on area of triangle, and if the vertex is same, right, the area of triangle ratio will be same as base ratio. Very, very important property, guys. 4:9 would be the correct answer to the question, guys. Thank you so much for watching the video, guys. So we have covered 16 questions. I'll be covering 14 more questions from the chapter of geometry, and then we'll be done with the complete 200 quant question series, guys. Thank you so much for watching the video, and please share it with all of your friends. You can subscribe to the channel to cover your 100% syllabus for CAT and OMATs, guys. Thanks a lot.